Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally, a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to the latest video. And in this video newsletter, well, what we're going to take a look at, how to screen a system using design of experiments. And in particular, what we're going to do is we're going to answer a client's query. Someone sent me an email. We're going to take a look at the email in a second. So we're going to say how to screen a set of variables. So I've been sent a question from a student. He sent me a few messages and I gave him some advice. He's gone away. He's identified the fact that he has 6 variables and he'd like a little bit of help on how to screen those variables down. So let's take a look. First of all, let's take a look at his email, and then Anil, I will give you some advice on how to screen your process. So let's take a look at Anil's email. Okay, he says, hope you're doing well. I just want to say thank you very much for helping in designing my IPO diagram. So there's a different video where I showed you how to draw an input-output diagram. Now I have 3 levels with 6 factors, and I have found that a full factorial design would have 729 experiments to be performed. I want to conduct a minimum number of experiments. It's FEA analysis, he says. And he's been advised that definitive screening design was a suggested technique on the internet, but I don't know how to do this on Minitab. Can you please help me out in this regard? I'll be waiting for your reply. Okay, Anil, well, you're asking me about definitive screening designs. I have to say, I'm not a user of definitive screening designs. However, we're going to take a look at that technique and we're going to work on that one together. So I'm going to learn something as well as you're going to learn something in this particular video. But I'm going to give you 3 options for doing this. So let's have a look what we've got. We say we've got 6 factors. And he says he wants to test them at 3 levels. Okay, so I'm just going to accept that. 6 factors at 3 levels. And the other thing he's telling me is he's doing it on finite element analysis. So he's doing this on a computer. All right, so it's not a process, it's not a machine. We're not having to go out and work hard to set the machine up. So I'm going to give you 3 options for doing your screening DOE. And actually the first thing I'm going to give you as an option is number 1 is not to screen at all. You tell me that if I go 3 to the power 6, I think you say it comes to 729 combinations. So here's option 1. When you're doing it on a computer, option 1 is, why not do the full factorial? Okay, now the reason I say that is because you're on a computer, and I know that 729 calculations, it seems like hard work, but I'd like to bet that if you sat at the computer and you had your model, you had your system in front of you, and you had to hand type in each combination and press a button to get a calc, it would probably take you a day, maybe a couple of days to do that. Now to me that's not hard work. you know, when I do a DOE, I could spend 3 days working on a machine, a real machine. We got to get out there, we got to do real setups. We might spend 3 hours doing the setup before we even generate any data. So on a computer, doing full factorials with lots of combinations is often okay. Sometimes the FEA software allows you to take a pattern, maybe in an Excel file, and to load that pattern in, and then to run the results overnight. You come in the next day and the data's there. So doing the full factorial might be an option. All right, so that's suggestion number 1 for you. Suggestion number 2 is using the Taguchi L18. Now the L18 in Minitab, it's on the Taguchi menu, and you have to select mixed level on the little radio button. All right. Now the L18 will test up to 8 variables. It will screen up to 8 variables. The first variable though is at 2 levels, it's not at 3, and that's why it's called a mixed level experiment. So one of the variables is at 2 levels, the other 7 variables are at 3 levels. So you could put your 6 variables into the L18 and it will screen. The analysis is graphs only. So when you do the analysis, you are going to create a factorial plot. You can see an example of a factorial plot here. This is a factorial plot for a different system, but it's just, you know, you can see that we had 8 factors in this particular system. I've therefore got 8 individual graphs. Each one of these lines represents the response that we got when we moved the variable from its low, middle to high setting. You can see that, you know, in order to screen, we're looking for the biggest signals. On this graph, you can see here's the biggest signal here. This would be telling us that the system is most sensitive to this variable. Then the second biggest variable is this one. So just by looking at this graph, if I wanted 3 variables that make my process result dance around, it's this one, it's this one, and it's this one. And then I could run a full factorial on those 3, which reduces your combinations right down. So you can do the Taguchi L18 with a simple factorial plot. It's on the Taguchi menu, mixed level, and then if you look in designs, you'll find it there. So that's option 2. Now that would be my choice, okay? So that's the one I normally use. What I would say to you is, with design of experiments, very few people use every design of experiments. People get comfortable with using certain experiments in certain situations. I like to use this one. I didn't have Minitab with definitive screening design, so I didn't have a choice, but I got into the habit of using the Taguchi L18. And your third option is a definitive screening DOE on Minitab. Now you mentioned you have Minitab 17. Now I've got to be honest, I don't know the versions and when they had different facilities on them. I have Minitab 20 and I have definitive screening designs on Minitab 20. I'm going to show you how to do that now. But one of my questions would be, I wonder if Minitab 17 has this on there, and it may not, in which case the L18 is going to have to be your weapon of choice, because the L18 will be on there. So let's go to Minitab and let's take a look at the definitive screening designs for you, Anil. And we'll both learn, because I don't use these, so we'll both see how to set up a definitive screening design and exactly what the experiment looks like, how short is it, how much time are you going to save over your 729, and how does it compare to the L18. Let's go to Minitab now. Okay, so here we are in Minitab. I'm just going to go to the DOE menu, so I'm going to go Stat, DOE, just to show you, Anil, Taguchi. If I go create Taguchi design, if I turn this up to 6 here, select mixed level, and then go to designs, you can see the L18, look, is one of my choices here. Okay, so that's how to find the Taguchi L18. I'll leave you to look more deeply into that. Let's cancel that off. But I'm going to look at the screening DOE. So I'm going to go Stat, DOE, Screening, Create Screening Design. Now when this window opens, look, you can see the radio button up here, look. There it is. It says Definitive Screening. So there's the option. Now obviously what I'm going to do, look, is I'm going to put 6 variables in here. I can go and look at the designs if I want to, so I can say how many replicates have I got and how many blocks have I got. Well, you're doing FEA, so you don't need to touch this at all. You can just cancel that out. So let's have a look at the available designs. I'm just looking, why aren't the factors alive? Let me go back here. If I click OK there, that's right, I've got to click OK in that first window. So when you go to designs, you have to click OK, and it brings all the other buttons awake then, so that you can then go and look at the other buttons. So we've put 6 factors in there, and as far as I can see now, the only thing I need to fill in, look, is the name of the variable and its high and its low value. Now just one thing to say about if you're going to use a definitive screening design, and I'm thinking, Anil, you won't have a problem because you're doing FEA. What we're about to say shouldn't be a problem to you. But what the software is going to do, you can see from the window that you're going to tell it a low value and a high value, and the computer is going to calculate the midpoint. All right. So whenever you do a 3-level DOE, you have to make sure that this middle value is possible. So for example, if you have a dial with numbers on and it just clicks 1 to 8, click, 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 click. There's no 3.2 setting or 3.3 setting. If you pick a setting of, let's have a think, if you pick 4 and you pick 8, well, the midpoint here, I think that's right, is it 5.5 or is it 6.5? Is going to fall at a fraction. It's not 5.5, I think it's 6.5. It's going to fall halfway between. So what you can't set that. So what you need to do is to make sure that you pick values where you can hit the middle value. So for instance, if you went 5, 6, 7. So if you pick 5 and 7, 6 is the midpoint, you can obviously set that. So, but if you went 5 and 8, I've then got to set this at 6.5. I can't set that on the machine. So you need to make sure that the middle value is settable, because the computer just calculates it, it picks it. You're not picking that value. Now on an FEA, I'm assuming that all possibilities are there, so it's a computer model. It'll be able to set the parameters accordingly, and also shouldn't be a problem in this case. But if you're doing this on a real machine, I've currently got a DOE where I've got valves, and the valve is at 15, then it can be at 22, then it can be at 37. Clearly 22 is not halfway between these two. So I've tested here and I've tested here in the experiment, this thing is a problem to me, because really I think I should be at 26, is halfway. So I actually can't get to the middle value, and that's making my DOE more complicated. Okay, so just be careful with that. If you've got a real experiment, the high, the low, and the midpoint must all be settable. Let's go back to the software panel, just finish this off for you. But I think you're okay. You haven't got to worry about that because you're doing FEA. Let's go back to Minitab. Okay, so we got the window there, look, where you get to name the variables and you get to put the high and the low in, as we were just talking about. So obviously, I don't know what the variables are. You haven't told me what the parameters are in this test, but you get to enter your 6 variables, your highs and your lows there. You put them in, and then you're going to click OK, and then you're going to click OK again. Let's see what it generates. And what we get, look, is this definitive screening DOE. It's 13 rows long. You can see that at the bottom. Let's have a look. It hasn't put zeros in at the bottom. I expected that it might do. There's something that I've done incorrectly. Let me just do that again. I'm going to go DOE screening. I need to go into options and switch off randomization. It randomized the pattern for me, and that just makes it a little bit more difficult to see the pattern. There's the pattern. Okay, so switch off randomization and then you can see the pattern properly. You can see there's 13 runs. The bottom row is everything at the midpoint. You can see the other settings. There's various settings. Some are at the middle, some are at -1, some are at +1. Obviously, if you've put the real values into that table, it won't say -1 and +1. It'll actually say time is at 10, time is at 5, temperatures is at 40 degrees, temperature is at 60 degrees, and the mid value is temperature at 50 degrees. So it will show you real values. But this is the definitive screening design, and you can see now it is shorter than the L18, but that's the definitive screening design, so that might be an option. Okay, so we can see now the version of the definitive screening design. This is 13 runs. You're going to do 1 repetition because you're doing FEA, which is a calculation. So you do 1 repetition here, you do 1 repetition here, you'd be doing 1 repetition here. So there is no value in repeating the tests in this case. So you're just going to come up with either 13 data points, 18 data points, or 729 data points. By the way, up here, you could model. All right, so you're not screening. If you do the full factorial, you're gonna model this. Okay, so that's important to know the difference. We're just using graphs here. So 13 runs or 18 runs. How are you going to analyze this? Same again. Factorial plot. Okay, so you're gonna have to, in order to do the factorial plot, you're gonna have to do regression first, usually, and then you can ask Minitab to create a factorial plot for you. I'm happy to help you further if you want help with the analysis on the factorial plot. It's exactly the same as the factorial plot here in terms of you're looking for the biggest signal, and then you take probably 3 or 4 variables that are big signals in your system, and then you model those 3 or 4 variables in order that you can make the system land on the target that you're aiming for. And what you've done now is you've screened down. So you've screened down from something which is potentially very complicated. You've only used 13 or 18 runs to do it, and then your next experiment will be about 30 experiments. Again, very easy to do on FEA. So now you've done what, 30 plus 13, you've done about 43, 45 experiments instead of 729 experiments. That's the power of screening. Screening saves you lots of time. It especially saves you lots of time when it's a real machine. When you 729 setups, I would never even entertain that advice to a client on a real machine. I would entertain the advice on a computer, however, but depends how much time this takes. So we are potentially reducing the whole thing down to just 45 tests for you to get the knowledge that you're looking for. So there is how to screen a set of variables on an FEA system. There's 3 methods that you could use. Anil, I wish you luck with your 13 run definitive screening design. If you have it on Minitab 17, don't know if it's there or not. If not, go to this one. It's only 18 runs. And you know, it'll do exactly the same thing as this factorial plot. You'll be able to screen down to 4 variables. If you need some help with it, let me know. And if anybody's got any questions about this, drop me a line. I'm more than happy to help.